morning, guys. We are going to start with the course of electronics. Electronics is more than the people think. Electronics in marine, the people normally say, is the connection of the GPS, the transducer, the fish finder, and that's it. No, my friend. Electronics is more than this. Those are electronic devices. But in your boat, you have more than those electronic devices. You have a lot of electronic devices. Basically, the majority of the appliances, the majority of the equipments today are electronics. Yes, with the green button, the arrow, you can go down. No, the other one over there. Down, press down, and keep the button pressed. It's okay. Yeah. Yeah, it's better. If you need more, close completely.
No,
All right. Okay, no problem. All right. Yes, electronics is everything today is electronic. For example, what is it? It's a simple example. I have a Chevy pickup truck, Chevy 1950, 50. It's 6 cylinders, inline, carbureted.
Simple.
What is the difference in between that truck and the new Chevy Silverado?
Injectors.
Excuse me?
Computer.
Yeah, the new one is exactly the same like the 1950, but is electronic. Electronic fuel injection, electronic cranking, electronic windows, electronic. But
Parts.
if you check the motor, the transmission, it's exactly the same. Oh, wow. Oh, it's incredible. The fuel consumption. the 1950 is exactly the same like the last Chevy Silverado. What is the advantage in technology?
Why do you say it's exactly the same except electronics? It's not the same engine.
Excuse me?
Why do you say it's exactly the same? You mean that it's a mechanical device?
Yeah, pay attention because in the old one,
Yeah.
the fuel mixed with the air enter through the carburetor.
Mm-hmm.
The carburetor is a mechanical element with the springs and needles and mixed the air and the fuel and enter the ratio 15:1.
14.
In the old one. In the new one, it's a sophisticated injector controlled by the computer and other flap that control the amount of air entering, and the computer control this movement with the throttle position sensor and this movement with the injector, and finally at the end you have the same amount of fuel and air. How was the troubleshooting in the old truck? That's simple. Calibrate a ball, less air, most air, less. Okay, you hear the RPM smooth, perfect, finito. This one, calibrate the new one. You need to go to the dealer, pay $1,000, and at the end you receive the bill. We need to replace 2 sensors, 3 condensers, 3 capacitors. Wow, that's incredible. This is a new truck. It's for me. Okay, I love electronics. This is one of my favorite topics. But the people use electronics to complicate a lot of things. We are going to learn in the next coming class this one. And I am going to explain, of course, both types. Mechanical fuel injection system, too simple. And electronic fuel injection system, no simple. Basically because they introduce 20 sensors, capacities. A lot of electronic devices that complicate the situation. The engineers say, no, it's because it's more safe. It's because it's more reliable. No, really no. The mechanical traditional systems were simple, easy to repair. I think that this is the problem, because those systems are easy to repair. The dealers, exactly, no manipulate the situation. Okay, in your boat you have millions of electronic devices. A lot of electronic devices. Not only the GPS, the transducer, those are 6, 7 elements that we are going to learn in this class, the procedure to install, the procedure to configure, the procedure to troubleshoot. But there are more than this. Let me explain something. What do you think is the main difference between an electrical circuit and an electronic circuit?
Computer.
Give me an example of one electrical circuit. In your home, in your car, in your boat. Electrical circuit.
Lights.
The circuit to activate the lights. Oh, the source of the power is over there in the cabinet where the power enters from the transformer outside. Enter over there. After that, the switch, and I activate the lights. This is an electrical circuit, no? The fan. You go over there, you turn on the switch, and you activate the fan. Those are electrical circuit because the motor is electric motor, because the cables are big cables, because the breaker is 10 amps. The electrical circuit is an electromechanical circuit with a movement of current more than 5 amps. And that circuit depends completely of me. I turn on the breaker, I turn off, I active, depend of me. If I turn off all the breakers in this building and I go home, during the evening, the lights start automatically? No, depend of me. I enter in the building, I activate the breakers. You understand? The electrical circuits have two important things. They manipulate high currents. High current, more than 5 amps, 5, 10, 20, 50. And depend of me. Completely. Completely, full. What about an electronic circuit? What do you think about an electronic circuit?
Air conditioning.
The air condition, look, this is the computer of a marine air conditioning unit. And you see the computer have relays, capacitors integrated in that circuit board. Okay, can I program this equipment, air conditioning equipment? I left my home and this equipment start and stop automatically? This is an electronic device, no? Electronic circuit. Those circuits are more
Complex.
more intelligent, more
Sophisticated.
correct. The electronic circuits are more sophisticated circuits. They are,
More independent.
excuse me?
More independent.
Complex.
Yeah, more independent. That's the word. Thank you. They are more independent than the electrical. Of course, at the end of the day, this one depends on me. No? The air conditioning unit depends on the programmation that I do in the thermostat. Yes or no? In your home. In your home, you go to the thermostat and you say, okay, I want this temperature today, enter, and I want that the air condition stop at 5 p.m. and start again at 6 a.m. Enter. That's it. Yes or not? And that configuration will be automatically start, stop, until I decide other situation. Okay, I am going to modify. Start 5 a.m. Stop 7 p.m. No weekends. The temperature a little lower. That's my new decision. Depend on me. Yes or no? Okay, it's electronic, it's intelligent. Right now, it's working by itself. But the first action was me. No? I decide the parameters at the beginning. After that, the system is completely automatic. Can I go to other country? Yes. That unit is working automatically. For how many days? Until I decide no more. Nice, no? The electronic circuits are more intelligent, more independent, thank you, more independent, but of course, at the end of the day, depend on me. Your car today is fully electronic practically, no? You can program it practically all the items, but depend of you. Depend of you. And also, depend of the manufacturer. The manufacturer can send information and block your car if you don't pay. No? This is for that reason the electronics are preferred is for business. For business is excellent. They can administrate, they can follow your car. Oh, that guy, 3 months, no payment. Okay, tomorrow, order, pick up the car, follow the car with this app, and the app founded the car wherever the car is. Wherever the car is. No?
There's Winn-Dixie when you're shopping.
Yeah. Okay, those are electronics. But we are going to go deep. How is the process to create a circuit? How is the process to create an electronic circuit? How is the process to create an electronic circuit board? And how can I convert this electronic circuit board in a small microchip? And yeah, it's a process. Now we are going to start with this. We are going to think in an engine, gas or diesel. In the engine, there are different jobs. For example, one situation is the cranking. You remember the cranking? From the ignition switch, the relay to the solenoid, and the engine starts. You remember that? Okay, I can create one circuit only for cranking. Okay, it's simple. I am going to buy one circuit board empty, like this. Yeah, full of holes. And I am going to install here, I am going to create here the circuit for cranking. Oh, Mr. Lopez, but I remember the ignition switch is big one, the relay is big one. Okay, okay. Exactly the same elements that you have in electrical circuits. In electrical circuit, you have relays like this, no? You remember? In electronic circuits, the relays are these ones. It's the same. With the same 1, 2, 3, 4 terminals. If you remove that one, they have 1, 2, 3, 4 terminals. Yeah? I have one relay for start, other for stop, other for run. Look at this. My engine analog used those big relays, switches, contactors, big one, no? And this one, electronic, everything is integrated here. Oh, nice. Oh, nice. Look at this. If you can see, this is the relay for start, stop. When I visit those countries, those companies dedicated to create electronic circuit boards, they say, okay, I can integrate those 3 circuits in one. How many boards, printed boards you wanted? No, I wanted 100. Oh no. For 100, each one will be $65. Each one? Yes. But if you order 1 million of boards, it's 0.1 cents per board. But I need order 1 million. You know the scale? If you order a little amount of boards, the price is practically is a lot. But if you order more boards, the price is less. Okay, all right, I don't need 1 million of boards, but I can order 10,000 boards. Okay, the price is $1 per board. Okay, that's good. For me, $1 per board is good. I return to my country, I assemble the boards, and I sell my engines. You understand? Okay, this is the printed circuit board for the engine. I integrate all the circuit related with the function of the engine here in this circuit board, and now this is the final circuit board. This is the printed circuit board, and this is the board with the elements soldered. You see the path of each circuit, the path of each circuit, and at the end of the day, I have a plug for input information, and this is the plug for output information. Nice, no? This is for the engine. Excuse me, but the transmission. Okay, I'm going to do the same with the automatic transmission. The automatic transmission is another robot, intelligent. It's similar to the air conditioner. It's fantastic. Okay, I need the process for the automatic transmission. Hey, Angel, can you design the circuit for forward? Sarah, you design the circuit for reverse. You design the circuit for neutral. You decide the circuit for the oil pressure on the transmission. You decide the circuit for temperature. Yeah? Tan, 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 tan. Once again, other 27 circuits. For first gear, second gear, overdrive, reverse, all the circuits. And now you create each individual circuit in a simple circuit board. I visit my friends in China, and they create the printed circuit board for the transmission. Ready? And now I have circuit board for engine, circuit board for transmission, circuit board for brakes, circuit board for, different circuit board for different systems in my car. I have 12 circuit boards for engine, transmission, brakes, lights, different circuit boards. I go to my friend and visit my friends in China, and I say, hey, my friends, can you integrate those 27 boards that I have for this sophisticated Tesla in one small microprocessor? You remember the microprocessor, guys? Unfortunately, I don't know where I put my microprocessor, but it's this. It's this. It's this. It's a solid piece of with metallic legs. You remember that? When you see the circuit boards, you see that element, guys? You remember that? This is the microprocessor. Wow! In this microprocessor, I can integrate 27 circuit boards, and those are the inputs, and those are the outputs. Wow! Yes, my friend, you can integrate all of those boards in one small microprocessor like this. You see? That small chip, that small microprocessor contains a lot of circuits. Circuit boards complicated like this. Wow. How many, try to think in your cell phone, how many microprocessors like this you have in your iPhone, in your Galaxy, in your Android? How many microprocessors of this? How many apps can you download in your phone today?
1,000.
Oh, I want the weather. Music. Oh, that microprocessor, a small microprocessor for music, have integrated how many individual circuits? Integrated in one small microprocessor. And that microprocessor integrated in other big microprocessor. This is the technology. It's a lot of people, no? For that reason, today you hear, what is doing that guy in the computer? Oh, he designed condensation of a circuit board. He designed condensation of microprocessors in one smaller. Yeah, it's people designing circuits, designing printed circuit boards, designing microprocessors, and designing computers. At the end of the day, you say, okay, this is the harness of my engine with transmissions and propulsion system, completely. And this is the computer. And those are the sockets for input information from the sensors, and this is the output information. And that's it. Because internally, I have one board like this, similar to this one. And that board is covered with resin and covered with this plastic container. In other words, I cannot change capacitors and nothing in that board. If this computer is damaged, what is the solution?
Replace.
You replace for another one. Because the dealer, they don't want that you repair like this open circuit board. If you have damaged that capacitor, you can desolder it and replace the capacitor, and you fix it. In the new technology, they don't want that you fix it. They cover it with resin, and finito. You cannot touch the electronic device. If it damaged one device, you need to replace the computer completely for new one. Everybody follow me? You enjoy that, guys? Is clear the explanation about the electronics? Electronics is more than a connected GPS. My friend, all of those electronic devices, GPS, transducer, we are going to connect those devices in 1 hour. Finito. I can finish this class today, but it's more than this. It's more than this. This is electronics.